I want us to try and prove some trigonometric identities in this video, and we are going to do this using example 18 on page 90. And on page 18, part A, we are supposed to show that 2 sine theta over 2 cosine theta over 2 multiplied by cosine theta is equals to a half sine 2 theta. And of course, coming from somewhere, there is some familiar statement here. And 2 sine, let's say this is A, 2 sine A cos A, we have known this to be equals to, or to be deduced from sine 2A, which is equals to 2 sine A cos A. Of course, in this case, our A is theta over 2. We can see that, theta over 2. From this, we can simply say that sine 2 times A, which is theta over 2 times 2, which is sine theta, is equals to 2 sine theta over 2 cosine theta over 2. It is important to note that how we have acquired this one. Let me just explain. This is from sine 2A, where A is theta over 2. Of course, when you multiply the 2, 2 and 2 cancels out, and you are left with theta. So in a nutshell, what we are supposed to be having here is, because this part, sine theta, is equals to this part. Please remember, this sine theta is supposed to be multiplied by cosine theta. Therefore, sine theta cosine theta. We are supposed to prove now this is our left-hand side. And this is now what we are supposed to prove to be equals to a half sine 2 theta. And again, from the same kind of understanding, that means sine 2 theta is equals to sine 2 theta is equals to 2 sine theta cosine theta. If you want to get this side, then you must be prepared to divide by 2 on the right hand side. But that division by 2 should happen on both sides. So when you cancel the 2, you'll be left with the left hand side, which is equals to a half sine 2 theta. And therefore sine theta cosine theta is equals to a half multiplied by sine 2 theta. That is what we are supposed to prove, and we have proven. Remember, we have just used one identity, which is sine 2A is equals to 2 sine A cos A, which has brought us to this particular expression. Part B of the same example, you're supposed to show that 1 plus cosine 4 theta is equals to 2 cosine squared 2 theta. And because both of them are expressed in cos, I would wish that we don't leave the cos. And we can see cosine squared here, and there is no square on this other side. But we know an identity. We know that cosine 2 theta, the way we know it, can be expressed by 2 cosine squared theta, cosine squared theta minus a. 2 cosine squared theta minus a. But you can see our theta now is not just theta, it's something else. So you can see our 2 theta is equals to 4 theta because we are taking this part to be this part. So we are saying 1 plus 1 plus cosine 4 theta to be equals to 1 plus 2 cosine squared 2 theta, because when we express cos 2a, this one is coming from cos 2a is equals to 2 cos squared a minus 1 cos squared. When we have 2a here, then it is cos squared a. So when we have 4 theta here, then it is 1 plus 2 cos squared half of this, which is 2 theta. Now, at that particular point, we now take these ones to be equals to, we take this one to be equals to, of course, that is minus 1. So that part now, let us write it afresh here. 1 plus 2 cos squared 2 theta minus 1. Of course, 1 minus 1 is 0. So we are left with 2 cos squared 2 theta on the right hand side. And this one is just proven. This is what we are supposed to have shown. And now that we have proven that 1 plus cos 4 theta is equals to 2 cos squared 2 theta as part B of example 18, then that is it. And that is what we are required to do. Remember, the identity we have used here is, now let me write it afresh because I don't think it's clear there. We have used, remember, it is important to remember the cosine of 2a to be equals to 2 cos squared a minus 1, which is also equals to 1 minus 2 sine squared a, which is also equals to cos squared a minus sine squared a. And of course, these are the two identities we have used there, but for this particular statement, we have simply used this. Not that we cannot use this. Yes, we can when it is required. Please note, every time you are expected to prove trigonometric identities, we use what we know. We use what we know. And it's also important to note that all these trigonometric identities that have been expressed here have been expressed before, because we can even continue to say cos 2a can also be written as cos squared a minus sine squared a. It is, you can use any of the three. But anyway, that is it, and I hope we understand.